the mole. Okay, we're not talking about the critter, right? We're talking about a very, very big number. And the reason why is because those darn atoms are so small, right? They're talking about if you made a single atom, it was the size of a dot made by a pencil. Whoop. All right, make the size of a dot. And the pencil would have to be 100 miles long, right? It would be, the pencil would have to be wider than a football field. It's crazy. So anyway, this number that we're going to, oh, Paul, turn it maybe after class. I just take the quiz. Then you won't get a 0. So let's see, what was I talking about? Oh, that's that atom size, right? Really small. So if we're going to be talking about anything in chemistry, reactions, drugs that intercalate into your DNA and fight cancer, whatever chemical compound you're talking about, we need to be talking about a huge number of them. So we're going to be talking about, when I mention that number, when we talk about it, it's going to be millions of billions. It's a huge, huge number. Can't even imagine millions of billions. So, but we can imagine a dozen. A dozen, Lauren, is how many? How many is a dozen? Dozen is 12. So if you had a dozen atoms, that's 12. Well, it's not going to do you much good. But the point is we could write ratios like this, right? A dozen atoms is 12 atoms. All right? So that's kind of what I'm saying here, right? Or the same as a ratio, a dozen per 12, or 12 per a dozen. A mole of atoms, though, that is, Audrey, what's the number? It starts with a 6. Anybody know? 0.022 times 10 to the 23rd. Millions of billions, 10 to the 23rd, right? A 6 with bloody 23 zeros after it. It's huge. And this number is referred to as, who got his name after this, Sydney? Starts with an A. Avogadro. Avogadro's number. Okay, let's play around with this a little bit. We have 0.0038 moles. So that's our measurement. Pretty much this whole class, you start with the measurement, and these problems, they get longer and longer and longer, more complicated, but it's the exact same method on how to solve them all, it seems like, that dimensional analysis. We want to start with the measurement, and we want to end up in C atoms. Well, we need the right conversion factor or ratio. Now, Megan, oh, Megan had to take off, that's right. Tanya. This unit of mole carbon has to go where? On the bottom. Okay, so what's the ratio? Yeah, that's that number, that's 6 times 10 to the 23rd, has to go on the top or the bottom. All right, let's see. 1 dozen equals 12. Here, 1 mole equals 6. So you could write it as this way. 1 mole all over 6. Yeah, so we have to flip it, right? So our ratio, of instead of a dozen per 12, we're talking about a mole per 6 times 10 to the 23rd. So, but she's right. We have to flip it because the mole has to cancel. All right, so you see that? We have to flip this ratio. Otherwise, our moles won't cancel. So when 1 mole, 6.022 times 10 to the 23rd. Well, a mole of anything is 6.022 times 10 to the 23rd of those things. So we're talking about a mole of C atoms, so that would be C atoms. Okay. All right, now here's a good thing to work on your calculator. Now let's battle it and figure it out. So, okay. So first you got to put in, right? Remember, everything on top multiply, bottom you divide. Yes, Mia? Did I lose you? Oh yeah, I gotta get off that green. That's hard to see, ain't it? Remind me, Mia. Yell, throw something. Well, don't throw something. Just yell. Right? So it's 6.022 to the 10 to the 23rd. I gotta get that off my palette. So what we have to do is multiply 0.038 times 6.022 to the 10 to the 23rd. So first put it in your calculator, 0.0038. Okay? You got it? Times. Oh, so fine. Hit the times button. So now you got to get this number, 6.022 to the 1023rd, in the calculator. So first you put in 6.022. Okay? Now the trick is getting the 10 to that power. Some folks like to use that 10 to the x button, but don't, because you're always going to be off by a factor of 10. So what the calculator wants you to do, this times 10 to any power is the exp. You push exp, and that's 10 to, and notice when you push it, a little double zero pops up in the upper left. Right? Was that left? Upper right. So then you just plug in the power, 23. Right? So you plug in 23. And if it was a negative 23, you'd push the little plus minus button, but it's not. Right? Just pop, and then hit equals. So then it gives you the answer in the same scientific notation. It gives it as, I'm not going to write all those digits. Oh, I'm still writing green, Mia. How do I get rid of that green? Let's do this one. 2 point, let's just round it to 29. Times 10 to the, what does your calculator say, Bowdy? 21. Make sure you can do that in your calculator, because you're going to have to do it at home for homework. Right? Giselle, you got it? Okay. So no problemas? We're good? Molar mass. The mass of a mole of substance. So pick a substance, and we want to figure out its molar mass. Right? So exactly a mole, that huge number of that compound, its smallest unit. Like here's 1 mole of sodium chloride, 1 mole of salt. Okay? What did I dump in this bag? So the point is I massed this out. But how did I know when to stop adding salt? How did I know when I exactly hit 1 mole? Here's sugar. C12H22O11, right? And I stopped adding when I exactly hit a mole. Okay, so how did I figure it out? Well, how do you find the mass of a mole of any element? So instead of worrying about the entire compound right now, let's just take a look at one element, sodium, right? How do you find the mass of a mole of sodium? You just look where? That little, what number is it going to be? 22.98. That's that molar mass of sodium. So you take 6.022 to the 10⁻23rd sodium atoms in nature, dig it all up, purify it, get it nice and clean. 6.022 to the 10⁻23rd sodium atoms. Now they're not all identical. Remember, some have a little bit more massive than others. You got that nuclide thing going on. Some have more neutrons, but they all have 11 protons. That's the main thing. But you get 6.022 to the 10⁻23rd naturally occurring sodium atoms. It's going to have a mass of 22.9898 grams, according to our little cheat sheet periodic table. So if that's what sodium is, 22.9898 grams. Chlorine is, what does that say? 35.453? What would be the molar mass of sodium chloride? You just figure it out how, Stephen? How would you figure it out? If sodium is 22.9898, chlorine is 35.453, what would be the molar mass of sodium chloride? Just add them together. Exactly. 22.9898 plus 35.453. 58.4 or so. So the molar mass of sodium chloride is 58.4 grams of sodium chloride in a mole of sodium chloride. Now a lot of folks are going to get lazy. They're just going to write 58, and I do too, grams per mole. But realize that's 58.4 grams of sodium chloride in a mole of sodium chloride. Okay. So that's how I knew once I hit 58.4, I stopped adding. How about the molar? We'll answer this in a little bit. The molar mass of sugar is, okay, you see the chemical formula there. See if you can figure out what mass I dumped in here. Right? It's going to be a lot more math. Right? Look at all the carbons, the hydrogens. You got 22 hydrogens. 11 oxygens. See what you get. Raina, did you get an answer yet? Did you get an answer? Try not to write any, to give you a hint, because you're going to be doing this a lot. Try not to write anything down. In other words, how I would do this is I would have the calculator and I'd just say, okay, 12 times carbon, look it up, plus 22 times hydrogens, look it up, plus 11 times 16, and then hit equals. That's, right, just get used to doing it that way. If you write stuff down, your homework's going to take you forever. What'd you get, Lorena? What'd you get? That's about what I got, something like 342, yeah. Right? So 342 grams per mole. 342 grams of, since we're doing this for the first time, we should write more units, right? Let's not get lazy yet. H22O11. It's supposed to be a subscript. 342, that's supposed to be a 3. 342 grams of sugar for every 1 mole of sugar. And we can get lazy later. Okay, some terminology that we need to get used to. The molar mass of sodium chloride, like we said, is 58.4 grams per mole. And may also be called, now Emily, you're always going to be safe calling these numbers molar masses. But since this is an ionic compound, sodium chloride, you're not supposed to call it one of these. Only one of these is correct. It's formula. And the reason why it's formula is because molecular has, I guess, the word molecule in it. So since sodium chloride isn't a molecule, sodium chloride is an ionic compound, but it's really a, what is this stuff? A crystal, right? They're crystalline. So these are crystalline. So there's no such thing as a molecule of sodium chloride. So you shouldn't call it molecular. That's right. You should call it formula units. The molar mass of sugar. Now, does this compound, does the chemical formula of sugar have a metal in it? It doesn't have a metal. So is it an ionic compound? No, it's not an ionic compound. You'd have, how do you know how to name this thing? How do you say 12 in Greek? I don't know. Right? So don't worry about it. But the point is that is a molecular compound. Even though, yeah, sugar has crystals, but it's crystals of molecules. So this is a molecular compound. So you can say molecular weight. The molar mass of sugar is 342 grams per mole. It's also called molecular weight. But just always call it molar mass, and then you never have to worry about the terminology, right? You can never be wrong if you just use the word molar mass. Okay. Some more terminology. Connor, 1 mole of sodium chloride consists of 6.022 to the 10 to the 23rd blank of NaCl. Formula units, exactly. Don't use the word molecules. Formula units, they're called. Kenneth, 1 mole of sugar consists of 6.022 to the 10 to the 23rd blank of sugar. Molecules, exactly. So that's a terminology we just got to get used to. Circle each molecular formula below and place a box around each formula unit below. So go ahead and do that. Circle all the molecular formulas, put a box around all the formula units. Circle all the molecular formulas and put a box around formula units. So Ashley, did you circle anything?
Yeah.
What did you circle?
C and E.
She circled C and E. Does everybody agree with the circles? All right, good. That means everything else should have a box. But just like the whole molar mass story, instead of using the word concerning yourself about saying molecular formula, formula unit, just always say what to describe this stuff. What formula? Chemical. Then you can never go wrong. What's the chemical formula of sodium hydroxide? NaOH. What's the chemical formula of carbon dioxide? CO2. So using the terms chemical formula and molar mass just makes life a heck of a lot easier. But, you know, it's the world we live in, so just got to get used to all this stuff. Mole ratios from chemical formulas. Okay, so what I want to do is get some mole ratios from a chemical formula. Now, how is this going to work? Rebecca, let's start with writing the chemical formula of iron 3 carbonate. What is the chemical formula of iron 3 carbonate? Fe. Now, hang on, before you keep going, put the charge on it. What's the charge on the iron? 3. So let's put a plus 3 up there. So then we'll know, you see what I'm doing now? I'm going to move that subscript down. Okay, now what's the carbonate? C. And it's polyatomic, so I'm going to use parentheses. C. Keep going. It's a 3. And what's the charge on it? Yep. Negative 2. Yeah. All those polyatomics, negative, except for ammonium. Okay, now we can do the subscript thing. All right. So it's Fe2CO3, iron 3 carbonate. Okay, let's write some mole ratios from it. All I'm saying, what's a mole ratio? Well, a mole of something over a mole of something. So we could say, if you have iron 3 carbonate, I'll put question marks here. How many moles of iron do you have? If we put a 1 in front of this, let's see, if we put a 1 right here, what does the bottom have to be? In other words, you can always say equals. 1 mole of iron 3 carbonate equals how many moles of iron? Look at the ratio. And what you can do is, how would you find the molar mass of iron 3 carbonate? How many irons would you take? 2 times Fe plus 3 times carbon. And how many oxygens? 9. So there's all your mole ratios. You just said to get 1 mole of iron 3 carbonate, you have to add how many irons? 2. So the ratio is just 2. How about in a mole of iron 3 carbonate, how many moles of, hey, here's a good one, carbonate do you have? What's the mole ratio there? Paul, what's the mole ratio there? In a mole of iron 3 carbonate, how many moles of carbonate would you have? 3. If you can see that, you're seeing the game I'm playing. Right? Make sense? Okay. So these are what I mean when I say mole ratios. Pretty much all you do is you look at the chemical formula and then just write ratios. Right? You'd have, for every 1 mole of iron 3 carbonate, you'd have 3 moles of carbon. That sort of thing. Okay. So why do we need that? Because of all of these types of problems here. Okay. So I think we should go to the boards and do this stuff, because then we can work together. You guys will work together on it better. So let's go to the boards and work on these. And this very first one, what is the formula weight of iron 3 carbonate? You know the game, just add it up on the periodic table. But you have to report your answer to how many sig figs? 3. That's the only thing it's asking for. Okay? So go ahead, let's give these a shot. You're going to need a calculator. And we'll work on these together. So spread out as much as you can to give each other space. There's 2 boards on the side here. Or Giselle, sitting, yeah, or Paul, jump in. Someone jump in over there too, for sure. All right. And a couple of you jump on this board. It'll help spread everybody out. Okay. Oh man, we're spread out really good. Steph, jump over here. You have a lot more space. Or some. Well, if you have room over there, that's fine. It's just these problems get kind of long. Oh, Paul's got it. Good deal. Okay, what is the formula weight of iron 3 carbonate? So again, try to do it all on your calculator. Try to do it all on your calculator. Because there really is no showing of your work here. You don't have a calculator, no. I've got a bunch of extra ones if you don't have a calculator. Yeah. Sarah, you need one? Iron 3 carbonate. So just add it up and see what you get. And then put your answer on the board and see if it agrees with the folks around you. And life will be a lot easier if you just get used to using the periodic table and adding it up directly on your calculator. And if you can't see the numbers, remember there's a periodic table in your course outline book. I think one in the front and in the back. Does anybody have an answer yet? Okay. So I see a 292 as an answer. Hopefully you're adding up 2 irons, 3 carbons, and 9 oxygens. Get 348. Two irons, 3 carbons, and 9 oxygens. So 2 times 55.845. Oh, you've got the times. But 2 times 55.845. Very close. Plus 3 times 12.01 plus 9, right? Times oxygens. Okay. So you guys get 292?
Yeah.
Okay, good. You got 292, go on to the next part.
How exactly do we write this part? The grams part?
Okay,
We already have-
so you start with this,
Okay.
and then you're going to put in the conversion factor of molar mass. So mole has to be on the bottom, grams up on top.
Oh, done. Okay.
So in B, you're converting moles of this iron 3 carbonate to grams of iron 3 carbonate. All right. You're just going to start out with the measurement. All right. End up in grams. And that conversion factor, that ratio you need, is the molar mass that you just found out from part A, right? And set it up so that the moles will cancel, right? So the moles have to cancel. I think that's why it might be best to write 292, that molar mass. Get used to writing it. Maybe don't skip that part. All right. It's probably easier to write the molar mass with that big ratio rather than just writing grams / moles, because it's kind of hard to see. Now, they're not after that Avogadro number, though, right? They're not after that, because that's if you wanted the number of atoms or something. All you're going to do is you're going to put in that molar mass, plug in this ratio right here. Just plug it in right there. And you'll have it. Because see how the moles will cancel? You'll end up in grams. All right, did you get around 1080 or so? So that's the answer. Or just 1080. So whenever you want to go from grams to moles or moles to grams, you can go either way. We're going to use that molar mass as our conversion. Now in C, they're asking for carbon atoms. So they want you to start with 3 grams of that iron 3 carbonate and convert all the way to carbon atoms. Okay? So try that one. Start with the 3 grams iron 3 carbonate. Go all the way to C atoms. So if I was going to do this, there's several ratios that you're going to have to do. You probably go from grams to moles, right? The molar mass. And then you can do that mole, you'll probably have to do a mole ratio thing to get into moles of carbon. then the last step would be carbon atoms. Let me show you that. I'll just put in the units to show you my thinking here. This is new, but you'll get used to it. This takes a lot of practice. Okay. So do you see my thinking there? So what I'm doing first is I got to get rid of these grams and get it into moles. Because the whole last step is to convert these moles of carbon into C atoms using that Avogadro's number guy, right? So that's the last step. But to get there, I got to get into moles of carbon. So that's what I got to do. So first I'll get it into moles of this iron 3 carbonate, because this grams stuff will cancel. All right. And then I've got to get rid of this moles of iron 3 carbonate, get it into moles of carbon. So my moles of iron 3 carbonate will cancel. And then my moles of carbon will cancel. We just got to put in the right ratios, the right numbers. See if you can figure out what those numbers will be. Okay. Yeah. And then C atoms. See if you can figure out what those numbers got to be. If you got it, help the folks around you. So remember this, grams to moles, that's that molar mass thing, right? 292. And the 292 goes with this. Yeah, that's a 1, and that's a 292. Right? The molar mass is always 292 grams per mole. But you could write it as a mole, 292 grams. Okay? Now here's that ratio that we talked about from chemical formulas. If you have 1 mole of this, how many moles of C do you have? 3. All right? Now if you have 1 mole of C, how many atoms do you have? That guy's number.
6.
That's
6 point.
Yep. Yep. And don't forget units of your final answer. You have to have units on there.
Nobody danced right?
I don't know. I think Connor got it. Connor got 1.8 times 10 to the 22. It's got to be a big number. Did anybody else get 1.8 times 10 to the 22? All right. Oh, and then write in all those. I mean, this works.
Yeah.
But write in the rest of the units.
I know. I just.
Yeah. That's fine. But just so that you see, it'd be a good habit. Let's put in those numbers. Yeah, I got the same thing as Connor. Should get about 1.86 times 10 to the 22. Should get about 1.86 times 10 to the 22. So if you got it, try D. D's your big test. Now if you didn't get it, let me or someone help you out who did get it. Make sure you can get that on your calculator. So now's the time to figure this stuff out. Make your life a lot easier at home. Okay, you got rid of the grams, now you're in moles. And this is for oxygen, right?
Mm-hmm.
So 1 mole of this, you have 9 moles of oxygen. And this looks good. So everything on top multiply, bottom divide. Anybody get an answer for D yet? 3.71 to the 10 to the 23rd? I don't know. I'll write it down and see if anybody else gets it. See if anybody else gets that number. Did you get it? Okay. I bet you it's right. 3 people got this. Make sure you can get that. If you can get it, see if you can figure out the trick or help the folks around you, and then see if you can figure out the trick to E. It's kind of a trick, but not much of one. Okay, how's it going? 1 by 3 carbonate. Okay, but see this will cancel with that. But this has to be down here. It can't be mole of O yet, because this has to cancel. So this mole of this whole thing has to be down here. Otherwise it won't cancel.
Oh, okay. So what goes? Oh, okay.
It's always a 1, and then this is going to be that number from the periodic table.
Oh, yeah.
That's that molar mass thing.
Okay.
So this has to be the mole of the Fe2 CO3, 3 of them. Okay. Now you're after the oxygen atoms or the carbon atoms?
The oxygen.
Oxygen atoms. Okay, now you do the mole of O up here and do that ratio. All right? So that's where you're going to get that ratio from this. There's actually how many oxygens here?
9.
9. So that'll be a 9, and that'll be a 1. All right?
And this is a 6.0.
Yeah, yeah. Well, I like to do this part first. That way I don't screw up. You're fine. But the mole of O goes down here, then atoms of O up there. That way, always you might end up putting the 6 times 10 to the 23rd in the wrong spot. Yeah, so whenever you have 1 mole of something, 6 times 10 to the 23rd of that something.
Oh, okay.
And just like in the molar mass, just remember that's always a 1. And this is always the number that comes from the periodic table.
Okay.
And that's the grams of everything you have to add up.
Oh, okay. That was too much.
Yeah. Yep.
On my calculator, I get the exact same answer, but I always get one more exponent.
So use EXP, don't use 10 to the x.
I did.
So remember that's why. You have to use EXP. Well, if you want to plug in 3.71 to 10 to the 23rd in the calculator, just say you did. You plug in 3.71 EXP 23. All right, let's see if you got so hopefully you got D. There's a trick to E. If you ever want to find the mass of any molecule, the mass of any molecule, if you want to get that, all you do is you divide something by Avogadro's number. What is that something? What is the something? If you want to get the mass of any molecule, and it's going to be a really dinky number, you divide something by Avogadro. What's the something? The what mass? The molar mass. Find the molar mass of that substance, divide it by Avogadro, and you'll have it. So now boron trifluoride would be what chemical formula? BF3. So add up a boron and 3 fluorines, and that's what you'd put in up on top. Divide it by Avogadro, and you have your answer in grams. So we have a couple minutes left. See if you can get it.
With the 3 sig figs?
Oh, yeah. It doesn't even. I think Dylan's got a good question about sig figs. I think the only time you worry about sig figs if it says report your answer to so many sig figs. Otherwise, you really don't care. Just always give 3 or 4 digits, and you're always good.
Okay.
Did you get an answer?
Yes.
What'd you get? 1.126 times 10 to the negative 22nd grams. Did anybody else get that number?
Yeah.
Oh, a bunch did. Good. Excellent. So come by, and I'll be glad to work with you on this stuff. We can do a few, and you'll end up flying through it. It will be as easy as pie. And then there's some more here if you want to practice on it, but.